Okay, now that we've learned how to find slope, we need to start learning how to create an equation given a graph or some information about a line. So this first section, we're going to learn all about the form y equals mx plus b. Now, the things you got to be able to do with all this is represented here. So you have to be able to determine the equation of a line using the slope-intercept form. That's what this called. That's what this is called. You need to understand what m represents. So you already know that m is your slope. And we've just talked a bunch about how to find it. Nothing changes on how to find slope. Okay. Now you also need to figure out what b is. Okay. So b is your y-intercept. So these are all things that we've actually all learned about. Okay. And now it's just a matter of being able to find this form given different scenarios. And we'll go over a bunch of different scenarios, and you can see these scenarios here. Now, terms, variables that we need to explain in this. So slope-intercept form is the equation of a line in the form y equals mx plus b, where m is your slope and b is your y-intercept. Okay, these are two things that you've already learned how to find. It's a matter of simply plugging it into your equation at this point. Okay, so remember, this is just kind of information that we already know. Y-intercept, aka b, the y-coordinate of the point where a line or curve crosses the y-axis or the range axis. So that's this point. If you have a graph and it goes like this point here is your y-intercept. Okay, remember, this is when x equals 0. So remember, if x equals 0, this is your y value. And in function notation, it's when if you have f of x and your x is replaced with 0. Okay, we've just talked about slope. Hopefully you just watched those previous videos before this, and it's about how to all find these slopes so you can find it graphically using rise over run or equationally. So if you have not watched how to find slope, you really need to go watch the videos that go through all of this, okay? Or else it can be very confusing. Now remember, slope is negative when trending downward or going right, and slope is positive when trending downward, or sorry, trending upward, going right. So this, yeah. So example 1, write an equation of the line in slope-intercept form. So recognize why it's called slope-intercept form. It's called slope-intercept form because it uses the fact that when you're given slope and you're given the y-intercept, you can determine the equation of the graph. Okay? So really understand that slope-intercept form is easy to remember because it's the one where it includes your slope and your intercept. So here, what are the slope and y-intercept? Write the equation. So for both of these, in order to write the equation, we need to, of course, know what a is, slope and y-intercept. So for this first one, let's focus on finding our slope first. So rise over run. It's given me a graph, so I'm going to do it visually. So remember, choose 2 points that you absolutely know are on your graph. So I see this point here, and this point, my x value is -3, my y value is +3. So this will be -3 and 3. Find another point on your graph that you absolutely 100% know is there, and that would be here, your point here. So this point, your x value is 0, okay? And what's your y value? Well, your y value is 1. So how do I get from this point to this point? Well, here you can see that our ticks are just simply going up by 1s here. So this will be 1, 2. So it looks like we're going -2 units down. Remember, when you go down, it's a negative. So that's our rise. Our rise is -2. Now, what's our run? Well, our run here, we're at -3 and we got to get to 0. So it'll be 1, 2, 3 units right. 1, 2, 3 units right. So this will be positive 3 units right. So our slope is negative 2 over 3. So that's our slope. Now let's find our y-intercept. And remember, this is just where the line crosses through your y-axis. So it's where your y intercepts your line. And we actually ended up using the slope, which is okay. And recognize this y-intercept would be where your y value is. So our y-intercept is actually 0 and 1. And this is the 1 value here, this is your y-intercept. So y-intercept equals positive 1. And now we have enough information to make the slope-intercept form of this equation. So my m value is negative 2 over 3. So I'm going to replace my m value right there. So y equals negative 2 over 3. And my x value, okay, I'm just going to keep there. So x. And now what's my b value? Well, my b value is the y-intercept. So my b value is positive 1. So I'm going to do plus 1. And there's the equation of this line. Now the cool part about this is now this is kind of an easier way to determine any value that exists on your line. So you can test it. Let's see what happens when x equals 3. So I'm going to plug in negative 2 over 3 times 3 plus 1. And let's see what that turns into. So negative 2 dividing 3 times 3 plus 1. And that's negative 1. So that's a coordinate point that exists on our line. When x is 3, y is negative 1. So this forms the coordinate points 3 and negative 1. Let's see if that worked. So when x is 3, it's supposed to be y at negative 1. And that actually worked. Perfect. And that shouldn't be actually that surprising because it should work. This equation represents any points found on this line. Okay. So remember, we use the fact that b is our y-intercept, which in this case was 1, and we found our slope and plugged it in for m. Let's look at this guy over here. So in this one, very similar thing. Let's find our slope. And again, I will do it using visuals first. So first off, find 2 points that you know absolutely exist on your line. So I'm going to choose this point here, which is x is negative 4, y is negative 4. So this will be negative 4 and negative 4. And then I'm going to choose this line here, or sorry, point. And in this case, this is x at negative 4, y at negative 2. Okay. And then from there, let's go visually. So it looks like each tick is in fact 1. So remember, slope is rise over run. And in this case, we're going up. So let's figure out our rise. So that's 1, 1, 2, 3, 4, 5, 6. So this is plus 6 units up. So my rise will be plus 6. And my run will be 1, 2, 3, 4, 5, 6, 7, 8. And it'll be plus 8 units right. Okay, so there is our slope. Now, I could leave it like that, but usually in math, you want to simplify. So let's divide both these by 2 to simplify it. So 6 dividing 2 is 3, 8 dividing 2 is 4. So our slope is positive 3 over 4. So every 3 units you go up, 4 units you go to the right. Now let's determine our y-intercept. Now our y-intercept, remember this is our b value. Our y-intercept where does this point cross our y in my y-axis? It's found right here. And what is that point? Well, that point is 0 and +1. Okay, or sorry, -1. So this is y at -1. So that's our y-intercept. Our y-intercept is -1. So that means our b is -1. So if we start solving for b and we want to find the equation of this line, well, we know what m is. I'm going to replace my m value with 3/4 x, and then I'm going to replace my b value with -1. So I'm just going to subtract 1 here. So there's one way to represent this equation. Now remember, in a previous video, we talked all about how slope can be represented using different fractions. So I could also represent this as y equals, and I could use this non-simplified version of my slope. So 6/8 x minus 1. And these are two viable options to represent this line. Both of these equations will work for this line. Not a problem at all. So just to prove you, just to try it out, I would suggest maybe plugging in x in this equation for 4, and you should get 2, right? If you plug in 4 here, you'll get 2 again. Okay, so give that a shot to see if it works properly. But you can represent equations, they should have the same y-intercepts, but the slopes can be similar fractions and it'll work just fine. So that's how to find it visually. Let's see some more examples where sometimes we're given certain information that we have to kind of figure out on our own. Okay, so for this one, example 2, determine the equation in slope-intercept form. So remember, slope-intercept form is where we're given slope and we're trying to find the y-intercept. In two different ways, if a graph goes through point P to -1 and has a y-intercept of 3. So if you're a very visual person, draw a rough sketch, okay? So we have point 2 and -1. So that's when x is 2, y is -1. And then we also have a y-intercept of 3. Now, if you draw a rough sketch, try and make your scales make sense. So a y-intercept at -3, so this would be roughly 1, 2, and I'm actually going to have to increase this a little bit up to +3 here. So there's my y-intercept. So this is a pretty steep line. Okay, you can kind of tell that we're going to go straight through here. So this is a pretty steep line, and it's also a negative slope. Okay, so when I solve this, I know m is going to end up being negative. Now, recognize you could do it visually, but I'm going to do it using I'm going to solve for m using my change in y over change in x equation. So y2 minus y1 over x2 minus x1. Okay, because this corresponds to a coordinate point. Remember, your y-intercept is when x is 0. So this is 0 and 3. So now I can name these two coordinate points because they exist on my graph. I'm going to call this one x1, y1, and I'm going to call this one x2 and y2. And I'm actually going to plug it in for this. So y2 and x2 is found over here, which is 0 and 3. And then y1 and x1 is 2 and -1. So now we can plug this in. So y2, I have decided to make 3. Subtract y1. y1 is -1. So I'm going to put brackets and put -1 here. So it's 3 minus -1. x2 is 0. And then x1 is 2. And then from there, we're solving. So you can use a calculator. You can also remember that a negative and a negative make a positive. So this is 3 plus 1. 0 minus 2. If you're bad at arithmetic, or not bad, but you're just not great at it, use a calculator, okay? Because there's a negative that's going to pop up here. 0 minus 2 is negative 2. And then you're going to get 4. 3 plus 1 is 4 over negative 2. And remember, we could technically leave it like that, but usually you want to simplify, okay? So this will become 2 over negative 1. And what's special about fractions is this negative can float. So you could either leave it like this and read it as every 2 units up, go 1 unit down, or you can just simply place it in the middle and keep it arbitrary. So whatever whoever's reading your math can either apply that negative on top or on the bottom. So I'm going to represent it like this. And recognize, simplified, you probably want to just represent it even as negative 2, because negative 2 divided by 1 is negative 2. But recognize that that 1 is always there. It didn't disappear. You have to remember that the run is still positive 1 in this case. Now, what's your y-intercept? Well, it told us our y-intercept. Our y-intercept is 3, so that means b equals 3. So now you have enough information to plug into your formula, okay? Because what was our m value? Our m value is negative 2. So I'm going to put negative 2x, right? The x, and then plus my y-intercept, so plus 3. And there is my solution. If it makes more sense to you to place it as negative 2 over 1x, plus 3, you're also welcome to represent it like that, okay? But remember, that 1 didn't disappear. Negative 2, a slope of negative 2, means that your rise equals negative 2 and your run equals positive 1. You just don't have to write the positive 1. Okay? So let's look at example 3 here. Example 3 is a little bit different. In this case, it wants you to determine the equation in slope-intercept form. So again, y equals mx plus b. If the line passes through points 3 and 2 and 5 and 0. So here it gives us 2 points to work off of. This time, again, you can always draw the graph if you'd like. You can draw a rough sketch. In this one, I'm going to challenge ourselves to not draw the sketch immediately, okay? So we have 2 points. How can we find m using 2 points? Well, if you're given 2 points and you're not doing it visually, of course you can always use the fact that slope equals change in y over change in x, which is y2 minus y1 over x2 minus x1. Again, list which values are which coordinate points. So 5 and 0, I'm going to represent as x1 and y1. 3 and 2 will be my x2 and my y2. And from here, now we're plugging in. So my x1 and my y1 are 5 and 0, so that will be these 2 values. My x2 and my y2 are 3 and 2, and that's x2 and y2 there. So now we can solve for slope. What's my y2? My y2 is 2. Subtract my y1, which is 0. Divide x2. My x2 was 3. Subtract my x1, which is 5. 2 minus 0 is 2. 3 minus 5 is negative 2. And here, recognize that both numbers are divisible by 2, because they are 2. So that's going to leave me with 1 over negative 1. So here, this can definitely get a little bit more strange. Some people find this a little confusing. 1 dividing by 1, -1, gives us -1. So the way we can read this is, and remember, if you have a 1 on the bottom, you can imagine it being there. If you like writing it, you are, again, welcome to. But we would read simply -1 for our slope as 1 unit down, go 1 unit right, because it's a positive number. You can imagine a little positive 1 there. And now from here, how the heck do we find our slope? Or sorry, we found our slope, so we have m, check mark that off, it's simply -1. Okay, now we need to find b. Remember, b is your y-intercept. Okay, how can I find b? I'm going to show you how to find b, because we know that you can find b using another point. So this is a new method that you're going to learn. Your point here, I'm going to use the fact that I have 3 and 2 on this line. So when x and y are 3 and 2, okay, I can solve for b algebraically. So this, so far my equation looks like this. Y equals -1 x plus b. Remember, x and y are just points on your graph. So when x is 3, y is 2. So I'm going to plug these values in here. So when y is 2, x is 3. So, and then I can solve for b. So this will be 2 equals -1 times 3 plus b. So I simply have now substituted a coordinate point into my equation. And now you can see I'm simply solving for a variable. So -1 and 3 gives me -3. So 2 equals -3 plus b. And now I can add 3 to both sides. So I will get 5 equals b. And there is my y-intercept, okay? So there's my y-intercept. So now I can simply plug in everything I know. Y equals mx plus b. So this is y equals m, which is -1 x plus 5. And there is my equation of this graph. Again, do I have to put 1 there? Technically, no. You could also represent it as just simply -x plus 5. Okay. So there is our graph, or our equation of our graph. If you were to draw this thing out, you absolutely could. So let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. So point 3 and 2, when x is 3, y is 2, so that's roughly right here. 5 and 0, well, that's an x-intercept. When x is 5, y is 0, so we're found right there. So this is 5 and 0. This is 3 and 2. And then we found our y-intercept at +5. So that's up here. And you can see that it does, in fact, create a straight line. Of course, mine's a little bit off just because my scaling is kind of funny, and I actually put our point, this point, a little off. You can see it's not perfectly lined up. So let's make that a little bit more accurate. So it'll be roughly right there. We can see that lines up pretty nicely. Okay. So recognize you could have drawn a little graph to begin with and then solved like we did up here, or you could do it algebraically. Knowing how to do it algebraically is very important, okay? So now we've been able to create graphs given information. Can we be given an equation and sketch the graph of that thing? Well, we absolutely should. So it's always important, start with your y-intercept. Okay, that's the easiest kind of thing to do here. So I'm gonna sketch a y-axis, and there's my x-axis. Now, my y-intercept is 5. So here I'm going to have 5. And there's my y-intercept. Now, let's create some scales here. So this will be 1, 2, 3, 4. 1, 2, that's a little off. 3, 4, 5, 6. -1, -2, -3, -4, -1, -2, -3, -4. Okay, there we go. So we already have a point here. Now, how do we go from here? We'll recognize -3, this is our slope, m equals -3. Remember what we talked about. If you have a whole number, you can imagine it being over a +1. And now we have some instructions. Remember, this is our rise over our run. So this is saying go down 3 units and right 1 unit. So go down 3 units, right 1 unit. So here I'll start at 5 and I'm going to go down 3 units. So that will be 1, 2, 3. So I've went down 3 units. And how many units am I going right? Well, I'm just going 1. So and then I'll go over 1 unit. So there is one of my plotted points on this graph. And then you would repeat. Go down 3 units. So 1, 2, 3. And then right 1 unit over. So there's another point on my graph. And then remember, the special thing about these graphs is you technically only need 2 lines. So if I join up all of my points, I could continue on forever and ever and ever. Okay. There we go, that's a little bit more accurate. So here, I'm going to say this goes on forever, and this goes on forever. So here is y equals -3x plus 5. Okay, and that will continue again on forever, and you only technically needed 2 points accurately. Okay, let's try this one. -1 over 2x minus 3. So here is our y-intercept. Okay, so if we create our graph here, so I will go -1, -2, -3, 1, 2, and then 3, -1, -2, -3, 1, 2, 3. Now we can start solving. So my y-intercept is at -3. So I'm going to plot my point right there. There's my y-intercept. And now from here, it's the same strategy. Figure out what your slope is and follow that instruction. So this is rise over run. So this is -1 over 2. Okay. So my rise is go down 1 unit, down 1 unit, right 2 units. Now, you might already see the issue here. If I go down 1 unit, I'm going off of how far I've scaled, okay? And I don't want to annoyingly have to make an even longer one. So what the heck am I going to do? Well, remember that this negative floats. So instead of following these instructions here, what I'm going to do is I'm going to represent my slope instead of -1/2. I'm going to represent it as 1 over -2. Why is this useful? Because now my rise is up 1. Up 1. And then my run, which is on the bottom, is now 2 to the left. And now I can use my graph more effectively. So I go up 1. So this will be up 1 here. And then 2 to the left. So 1, 2. So here's 2 left, up 1. Okay, and now I have a point found right here. And I can create one more line. So up 1. Oh, that was an up 1, sorry. Up 1, so right here. And then 2 to the left. So it looks like I'll have to extend this by just 1 here, because I'm going to go 2 left, 1, 2. And there is my point. And now from here, we can connect. And remember, you technically only needed 2 points, and this will go on and continue forever. So, of course, my scaling is a tiny bit off, but as long as things are matching up pretty accurately, that's all good. So this, recognize this point should technically be on this graph. Perfect. And there is our slope. So there I've utilized the fact that my negative symbol kind of floats in my fraction there. Now let's do this last one here. So recognize immediately your y-intercept is super useful. So there's my y-intercept. So I'm going to start off my graph here. And I'm at -2, so this will be -1. This will be -2, 1, 2. Okay, so there's my y-intercept, done. Now, this is a confusing thing. It's just simply x. So lots of people might think slope is 0. But slope is not 0 here because you can imagine a 1 there. So this is 1. Now remember, any number where it's just a whole number, you can imagine it being 1 over 1. And now you have your rise over your run. So my rise is +1, my run is +1. So here, this is up 1 unit, and this is right 1 unit. So now we can use our point that we've plotted, our y-intercept, and start graphing this. So we're going to go over 1, 2, 3, -1, -2, -3. So from here, every time I go to the right 1, I go up 1. So there's our new point. And then I go right 1, up 1. There's our x-intercept, right 1, up 1. And now we can connect all of these points. And if I made the scale perfect, it will go through every single point. And there is our graph of this equation. So this graphed y equals x minus 2. So there was a lot of information there. I'm going to stop at that, and then the next video we'll do some word problems. But recognize that there are a few different ways to find your equation. If you're a very visual person, there's always a way to roughly sketch your graph with the information given. If you're more of an algebraic, more problem-solve type person, you can actually solve it. And remember, this is a really important, useful point. If you have your slope and then a point that exists on that graph, you can find your y-intercept algebraically. Okay? So lots of new information going on here. I'd really recommend going and trying a few problems out on your own, open up your textbook, or watch some other videos, or of course, come in for help. Other than that, have a good day.